Well, the question is a block of mass 1 kg slides down a curved track which forms one quadrant of a circle of radius 1 meter as shown in the figure. The speed at the bottom of the track is 2 meter per second square. The work done by the force of friction is, well, actually, at different point, the frictional force will be different. So directly we cannot calculate the work done through the integration process. But we will do it using the work energy theorem. We know that work done by all the forces is equal to change in kinetic energy. So all means what? Gravitational force is there, normal force is there, and the friction force is there. Okay, apart from this, no other forces are there, which is equal to half m final velocity square minus initial velocity square. Okay, change in kinetic energy. Work done by gravity only depends upon that vertical height only. So work done by gravity is what? Plus m z h. H is 1. Okay, vertical height. Work done by normal will be 0 because all the time you can see normal is perpendicular to the tangent, means perpendicular to the displacement. So work done by normal will be 0 only. Work done by friction, we don't know, we will calculate it. Equal to half m, mass is 1 only, and here the velocity is 2 meter per second, and initial velocity was 0 because it is released only. So 1 into 10 into 1, that is 10 only, plus wf equal to 2 to the 4, 4 by 2 is 2. So work done by friction is what? Minus 8. All are in SI, so answer is in joule. So work done by friction is minus 8 joule. So it means the third option is correct.